piecewise defined functions. Usually when we have a function, we have a simple rule. Like normally when we have a function, we have something like f of x equals 3x plus 5. And if I wrote this symbol, f parenthesis 2, what does that symbol mean to do? It means plug in 2 for the x number. And I would plug it in, I would have 3 times 2 plus 5, and that's 11. A piecewise function is something that looks like this. Why is it called piecewise? What's that? There are different parts. So this function sometimes is 2x minus 1, and other times it's x plus 3. And this function is split on its domain. There's a word I don't think I've used before in this class. What does domain mean? The domain is the set of x values. That's exactly correct. What's the range? The set of y values. Okay, so this function is going to be the line 2x minus 3 anytime your x value is less than or equal to 0. Conversely, it's going to be the line x plus 3 when x is a number bigger than 0. So it's piecewise. It's called piecewise because it's split into 2 different pieces. And of course, that could be more than 2, as you can see in example 2 that we're going to look at in a minute. We have a function split into 3 pieces. That can happen also. Okay, so part A here, it says evaluate f at negative 3. How would you evaluate f at negative 3? You would use the 2x minus 1 rule. How come? Perfect. Negative 3 is less than 0, so that tells you you're going to use the 2x minus 1 rule. So if I want to plug in negative 3 into this function, I'm going to take 2 times negative 3 and subtract 1. I work that out, I get negative 7. How about f at 0? I use exactly the same one because this one is the one that has the equal to. So the equal to is here. I take 0, I plug it into there. 2 times 0 minus 1, that's minus 1. Now I think f at 4 is different. Why is f at 4 different? I use the other rule, don't I? 4 is bigger than 0, so to plug 4 in, I use the bottom rule. So that's going to be 4 plus 3, which is 7. Questions on that so far? Okay, now it asks me to graph this function. What I like to do when I'm told to graph a piecewise function, I like to come off to the side here, and I'm going to draw a very rough sketch of each of the 2 functions. So I'm going to graph y equals 2x minus 1, and I'm going to graph y equals x plus 3. And then when I'm done, I'll take the appropriate pieces and put them onto my final answer. How would you graph the equation y equals 2x minus 1? Our y-intercept is 0, negative 1. My slope is 2, so I go up 2 and over 1. And then I could do it again, up 2, over 1, and I play a game of connect the dots. There it is. Okay, and how about the graph of y equals x plus 3? My intercept is not the origin. My intercept is 3.
And it's just going to be a horizontal.
No, it's not horizontal. What's my slope right here? What's the number right in front? 1. So what's that slope tell me to do? Up 1 over 1. So I'm going to go up 1 over 1, up 1 over 1. Now, my scaling on these 2 graphs really isn't very good, because these 2 graphs look almost parallel. Should these two graphs be parallel? No, why not? They have different slopes. This one has a slope of 2, this one has a slope of 1. So my scaling isn't very good. We'll do it better when we get over here. All right, so I'm going to label my axes. I'm going to go by 1, so 1, 2, 3, 4, 5, 6. And then here we'll go 2, 4, 6, negative 2, negative 4, negative 6, and negative 2, negative 4, negative 6. Okay, so now I want to graph this function. I want to graph 2x minus 1, but I only want the part where x is less than or equal to 0. So I look at this graph. Here's my graph of 2x minus 1. Where's the part where x is less than or equal to 0?
To the left of the intercept.
To the left of the intercept, because this is where x equals 0, and I want x to be less than 0. X less than 0 means go to the left, doesn't it? So I want to take this part of the graph and transpose it to over here. So that looks like I had 0, negative 1 as my intercept, and then my slope was 2, so I'm going to go down 2 and left 1. Down 2 and left 1. Connect the dots. So I get a line segment as part of my graph. And then I do the same thing with the other one. The other one, I want the graph of x plus 3, but I only want it when x is bigger than 0. So what do I want? I want to go to the right. What's going to happen right at this point, 0, comma 3? Am I going to put a dot there?
Circle.
A circle. Excellent. Why would I put a circle there and not a dot? Because it is just greater than, there's no equal to, is there? So I should put a circle right here at 0, comma 3, because there's no equal to, and I'm going to shade to the right this time, because this time it's x is greater than 0. Okay, so I go to 0, comma 3, I put a circle, and then I go, my slope was 1, so I go up 1 over 1. Up 1 over 1. And I get a line that looks like that. So there is the graph of that function. Notice the function had 2 separate parts, so we get 2 separate graphs, in a sense. Questions on that one?
Can you explain the first
This line?
Yes. On the graph.
On the graph.
Yes.
Okay, so once again, I wanted this line, except I didn't want all of the line. I only wanted the part where x was less than or equal to 0. So I started where x was 0, that was right there. And then I wanted x to be less than 0. So x less than 0 means go to the left, correct? So that means I want that part of the line. So I came over here, and I started at 0, comma 1, and then I drew that part of the line. And I was more specific about my slope to make sure that when I did it, these two things didn't look parallel, because they really shouldn't. So when we drew this originally here, we went up 2 and over 1. When I did it over here, you can do the same thing, except I went down 2 and left 1. So slope, you can move slope in either direction. You just have to make sure you get your signs right. So it's either up 2 over 1 or down 2 left 1, whichever way you want to go. Other questions? You can use your calculator to graph these functions. I'm going to go to y equals. The first thing I want to do, notice on my graph, I got that stat plot turned on. I want to turn that stat plot off. The quick and easy way to turn a stat plot off is to go to y equals, and see that black box up there? That's your stat plot. Go up and hit enter. And that turns that stat plot off. That's the quick and easy way to turn that off. Okay, to type in a piecewise function, you do it in kind of a strange way. You're going to take the first rule, which is 2x minus 1, and you're going to put it in parentheses. So you're going to write 2x minus 1 like that. And then the word if on the calculator is the divide symbol. So you divide, and then you put another parenthesis, and you have to type in x less than or equal to 0. So you got x. Anybody know where to find the less than symbol, or the less than or equal to?
Second math.
Second math, excellent. Second math gets you into the test menu. Second math, and all of those symbols are down there. We go down to less than or equal to 0. So I type that into y1, and then I go down to y2, and I do exactly the same thing. I type in the second part. Again, it's got to be in parentheses, x plus 3, close the parenthesis, divide by, and then another parenthesis, x, go into that test menu, greater than 0. Now, I don't just want to hit the graph button. How come I don't want to hit the graph button?
You would be close to.
Because I've got that weird window that I had from the problem I was doing before. So don't just hit graph. A good idea, never hit graph. Hit zoom 6 is a much better idea, and that gets you into your standard graphing window where it goes 10 to the right, 10 to the left, 10 up, 10 down. Now, the calculator does a pretty good job, but the calculator does make a mistake. How is the calculator's graph different from my graph? There's one tiny little difference. It doesn't have the dot or the circle. That's exactly correct. The calculator doesn't draw, well, in fact, I would kind of argue that it looks like there's a dot there and a dot there. The calculator will not draw where the dot belongs and where the circle belongs. So if you're going to use your calculator to draw these, that's fine. But when you go to put it on your paper, you need to recognize that this one gets the dot and that one gets the circle. And if you don't put the dot and the circle on your graph, of course, I will take points off. Okay, so watch out for that. Make sure if you use your calculator, you need to understand where the dots and the circles go. Okay, let's try number 2. Consider the function, and this one's split into 3 pieces. 3 minus x if x is less than negative 4, x if negative 4 less than or equal to x less than 2, and x plus 1 if x is greater than or equal to 2. It tells me plug in negative 4. When I plug in negative 4, which rule do I plug it into? The one in the middle. Why the one in the middle? That's where it has the equal to negative 4. So I plug negative 4 into the one in the middle. That's real easy. I get negative 4. Negative 3 also gets plugged into the middle. So that one's going to be negative 3, negative 2, negative 1, 0, 1. All of those get plugged into the middle one. The middle one doesn't do anything. Finally, something new. What happens when I take and plug in x equals 2? I get 3 because now I have to plug it into the bottom rule, don't I? So that's going to be 3. And when I plug in 3, 3 plus 1 is 4. Okay, so it's important that you be able to build a table like that you know which rule you have to plug into. All right, sketch the graph. Do we want to do it on our calculator or do we want to do it by hand? Calculator, okay. Flip it back over so I can look at it. Y equals, figure these out, I guess. So this time I'm going to have to type in 3 pieces, correct? Parenthesis, 3 minus x divided by x, put up a test, less than negative 4. The next one, x divided by, parenthesis. Now, I'm going to warn you on this one. I'm not sure if this is going to work or not. -4, go to the test, less than or equal to x, go to the test, less than 2. This might not work. I don't remember if this is something that got corrected or not. It used to be that when you had a compound inequality like that you had to split it into 2 sets of parentheses. So we're going to try it and see if it works. And what might happen is it might work on some calculators like mine, which is a newer one, and it might not work on others that are older. We'll see. We'll try it first. We'll see if it works. And then finally, x plus 1 divided by x greater than or equal to 2. Zoom number 6. Okay, so looking at my answer, it didn't work. That middle one is wrong. How can I tell that that middle one is wrong?
It doesn't stay between.
It didn't stay between -4 and 2 like it was supposed to, did it? That middle one is just y equals x. It drew the whole entire line. It shouldn't have done that. It should only draw that whole entire line between -4 and 2. So you can tell that it didn't work because the graphs overlap. This one and this one overlap. This one and that one overlap. Okay, so I didn't think that was going to work, but I wanted to try. So we're going to go back to y equals. This one, we're going to have to write as negative, we're going to put the parenthesis, -4 less than or equal to x, and then we've got to close the parenthesis. And then I think we start another parenthesis, and we put x, go to the test, less than 2. Okay, so if you have a compound inequality like that, unfortunately on the calculator you have to split it into 2. It won't read it as just 1. Now let's push the graph button. We get part of a graph, and part of a graph. That's much better. That's what it should look like. Now, how are you going to draw that on your piece of paper? Well, you might kind of want to try to figure out where is this point right here on the calculator where this graph is starting. So what does that look like? It looks like it's -4, and then it looks like it's about how high? About 7? And that makes sense, right? Because if I plug in -4 here, I'm going to have 3 minus -4, which is 7. But again, I need to be careful. When I draw the point -3, 7, or I'm sorry, -4, 7, do I put a dot or a circle? Nope. A circle. Why a circle? There's no equal to on that -4. Okay, so I'm going to have the point -4. That's 1, 2, 3, 4, 7. 1, 2, 3, 4, 5, 6, 7. Oops, I went and put a dot there already, see? -4, 7. And then the line went that way. And then the chunk in the middle starts when x is -4. So this is the point -4, -4, and ends at the point 2, 2. And again, we need to be careful. This one gets a dot at -4, -4. At 2, 2, however, there's no equal to sign there, so we're going to have a circle. Okay, so I'm going to have -4, -4, 2, 3, and a dot right there. And then at the point 2, 2, oh, see, I made that mistake again. It's just so habit. You're so used to putting a dot there that you put a dot there out of habit. It really should be a circle. So we'll put a circle there. And then finally the last part. When we plugged in 2, we got 2 plus 1, that's 3. So I've got the point 2, 3 right there. And then the line that goes up. So, on a quiz, on a test, on homework, that's the kind of answer I would expect to see for that problem. Questions on that? Yes?
My graph turned out like really weird.
Your graph turned out really weird.
Yeah. That's all it shows.
Yeah, I agree. Your graph is really weird. Okay, so I see a couple things. One, you've got your stat plot turned on. So we turn that on. We turn that off. Two, you didn't put parentheses around the x less than -4, and you didn't put the parentheses around the x greater than or equal to 2. And so that's why it didn't work out. Okay? Got to have those parentheses there.
Thank you.
You're welcome. Yes? Yours did something goofy too. Let's see. -4 less than or equal to x. X. This one should be x is less than 2.
Oh.
You have greater than. All the calculator issues. All right, now let's go backward. What do I mean by go backward? Well, now they're giving us a graph, and they want us to come up with an equation. How are we going to do that?
You can start with the intercepts.
We're going to start with the intercepts. First off, for this equation, how many pieces are we going to need? 2. Why do you clearly see that there are 2 pieces?
Just 2 lines.
Because there's 2 lines, 2 different pieces. All right, so what I would do is I would start by writing f of x equals, and then we have this curly bracket. And then we're going to have one equation and another equation. We'll figure out what those are in a minute. I'm going to put the if words in there. What am I going to have over here for my domains? That's where I usually start, is with my domains. What about this line right here, this line segment? What's the domain for that? Which x values is it using?
Less than.
X less than. This one doesn't have the equal to because it's got the circle right there.
3.
Nope, 3 is a y number, isn't it? What's the x number right here? This is the point 0, 3. So x here starts at 0 and goes to the left. So you got to be very careful here that you're using your x numbers. So my domain for that part, x starts at 0 and goes to the left. How about my domain for the other part of the graph?
Goes to the right.
And it has the equal to, doesn't it? So x is greater than or equal to 0. All right, now, how are we going to figure out the equation of this line? Well, to figure out the equation of a line, the most important thing to know is
The slope.
the slope. What's the slope of that line?
Which one?
This one.
2.
The slope is 2. And how did you determine that the slope was 2? You started here,
No.
you went down 2,
Oh,
and over 2, that doesn't quite hit.
it's 3 over 2.
Down 3 over 2?
Down 3 over 2.
If I go down 3 and over 2, that doesn't quite hit the line. I'm over here.
Down 1.5.
All right, so you're getting close. You got the idea. This is what you want to do. What you want to do is you want to find another point that hits right on the line. It looks like right there. 2, -2, comma, -1. Looks like it hits right exactly on the line. And so then you're right. All you need to do is count. So if I go here, I go up 1, 2, 3, 4 places, and I go to the right 2. So I would agree. My slope looks like it's 2. Agreed? So my slope is 2, so that's 2x plus, what's my intercept? 3. It crosses right at 0, 3, doesn't it? So there's the first line. How about the second line? What's the slope of that one? I would say it's -3 because it looks like it hits right there at -3, or I'm sorry, 1, -3. So if I start at 0, 0, it looks like I go down 3 and over 1. So I would say my slope on that one is -3. So So I'm going to have negative 3x plus, what's my intercept? 0, right? It's right at 0, so I don't need to write 0. So there it is. There's my answer. Questions on that? All right, I think we'll have time to do number 5, and then I don't think we'll have time to do the other 2. We'll do those on Wednesday because we don't have class on Monday, do we? All right, so number 5, looking at number 5, how many pieces are we going to need? 3. So we'll have f of x, 3 pieces. And again, I like to start with my domain. So looking at this piece on the left, what are the x numbers that are used on this one? Less than negative 1 or less than or equal to negative 1?
Which one are you doing?
Okay, so on this one you have a choice, don't you? Because this one and this piece happen to match right up at the same spot. One of them is going to get the less than, and one of them is going to get the less than or equal to, and you get to decide which one.
Just the less than.
Okay, so since these two happen to match up perfectly, we're going to put x less than negative 1. How about the piece in the middle? It goes from negative 1 to 1, so that's negative 1 less than or equal to x less than 1. Less than 1 because there was no dot there. And how about the last one? Starts at 1 and goes to the right, so x is greater than 1. I'm going to do the one in the middle first. What's the equation? That's a horizontal line. What's the equation of a horizontal line? Not 0. Not undefined. That would be a vertical line. The slope of a vertical line is undefined.
Like x equals y.
X equals a number would be a vertical line. So it's y equals a number. Y equals a number is a horizontal line because your slope would be 0. You have mx plus b. M is 0 on a horizontal line. So you just have your b number. So y is what value here? 2. So the middle equation is just 2. Don't really have to do any work with that one because it's horizontal. All right, how about this first one? Well, let's see. It looks like it has the point negative 1 comma 2. And it looks like maybe that point right there, negative 3 comma 0. I need to find the equation that goes through those 2 points. How am I going to do that? Well, if you're looking for the equation of a line, the most important thing to always know is slope. So I'm going to find my slope. M is 2 minus 0 over negative 1 minus negative 3. That's 2 over 2. That's 1. Do I happen to know the y-intercept? No, but I think I can figure it out real easily. Because my slope is 1, so if I wanted to find the y-intercept, what would I do from right here, this point, negative 1 comma 2? If my slope is 1, I would go up 1 and over 1. So my intercept is 3. So I think this is the graph of x plus 3. And then finally, I need to do the exact same thing with the last one. And just because I'm out of time, I will tell you that the slope of the last one is also 1. And you should believe me because this line and this line look parallel. Yes? Believe me? Okay, my slope is 1. And so I can do the same trick to find my intercept. I can go down 1 and over 1. My intercept is going to be negative 1. So this one is x minus 1. Okay, so we'll come back to class on Wednesday. We'll answer problems 6 and 7. We'll have an idea of where are these piecewise functions actually used in your real life.